In today's note, we're going to be looking at the interior and exterior angles of polygons. We've already looked at this for triangles, but what we're going to do now is look at this for any type of polygon. So we have an investigation, and we should have gone through and found what the sum of each interior, what the sum of interior angles are for each polygon by measuring using a protractor. So what we want to do first, though, is I'm going to show you an easier way to help you figure this out, and then we'll work at looking at the formula. So for the sum of interior angles, for a triangle, we should already know what the sum of interior angles of a triangle is, and that is 180 degrees. Now, for a four-sided figure, or a square, or a quadrilateral, we may not know exactly what it is. From a square, though, we could tell that it is all right-angled triangles, so you could do 90 times 4 and figure out that it's 360 degrees. What you could do, though, if you weren't sure, what you can do is pick one corner of your polygon, so I'm going to say this corner here, and you're going to try to draw a straight line to the other corners without intersecting any lines that are already drawn. So I can't draw it straight down because there's already a line there. So my only option is to go right to the opposite corner. And basically what I've done is I split this up into two triangles, triangle 1 and triangle 2. Now I have two triangles. I already know from the last note and from the first one that the sum of a triangle, or the sum of interior angles of a triangle, is 180. So all I've done here is I have two triangles, so 180 times 2, which is 360. If I do that for my next one, again, I'm going to pick a point, and I'm going to try to draw as many triangles as I can without intersecting any lines. So here, that's as much as I can do. 1, 2, 3. So I have three triangles now. So three triangles, or 3 times 180, gives us a sum of 540. Let's try it for the next one. Again, same thing. Try to draw as many triangles as you can from one point. Again, it doesn't have to be perfect as long as you get the rough idea. And here we have 4 triangles. So 4 times 180, we get 720. We can go next one. You might be able to see a pattern. So as I draw through it, of 1, 2, 3, 4, 5 triangles. 5 times 180 is 900. And you can kind of see the pattern that we're going through. So we just keep on picking a point, trying to draw as many triangles that we can, and then multiply that by 180. Now, if you don't want to go through and multiply or draw triangles, maybe you don't have the shape for you or drawn for you, so you have to go through and draw it yourself, and it may be inaccurate. Let's see if there's a pattern between the number of sides and the triangles. So if I look at my triangle, I have 3 sides, 3 sides, and 1 triangle. For the quadrilateral, I have 4 sides and 2 triangles. For the pentagon, 5 sides and 3 triangles. For the hexagon, 6 sides, 4 triangles. And for the heptagon, I have 7 sides and 5 triangles. And if we look at those numbers, the pattern that we should see is that for the number of sides, if I take away 2, that tells me how many triangles there are. And once I find out how many triangles I have, I just multiply that number by 180. So that is where we get our formula n minus 2 times 180, where n is the number of sides. So for example, if we want to determine the sum of the interior angles of a 12-sided polygon, that means my n is equal to 12. So in my formula, 12 minus 2 times 180. 12 minus 2 is 10. 10 times 180 is 1,800. Or basically what that's saying is that if I have a 12-sided figure, I can draw 10 triangles. Which means then 10 triangles times 180 degrees each gives me 1,800 degrees. And we can use this formula in the other direction. If I know the sum of interior angles, I should be able to find out how many sides does my polygon have. And we can work through this backwards. So if I have 2,000, or the sum of interior angles works out to 2,160, and I want to work backwards, I want to figure out how many triangles can I make out of this. So to figure that out, I'm going to divide 2,160 by 180, which works out to 12. And this means I have 12 triangles. That doesn't quite help me with how many sides it has, but if I know from before that the pattern is the number of sides minus 2 gives me the number of triangles, or n minus 2, that means I have to take 12, add 2 to it, or the number of triangles, which is 12, plus 2 equals 14. So therefore, it has 14 sides. And if you want to think of this algebraically, if we have our formula s equals n minus 2 times 180, s is 2,160 equals n minus 2 times 180. I'm going to divide both sides by 180 to cancel it out. We're left with 12 equals n minus 2. Going to add 2 to both sides, and we get 14 equals n. So either way you want to think of it, if you're working backwards from your understanding of the formula, or just solving the formula because it is an equation, you still get the same answer. Lastly, if we look at the sum of exterior angles on polygons, if we look at these three diagrams, the exterior angles, remember again, are the ones on the outside. So I'll draw them in on my three shapes here. And what we should find when you go through and you look at all the sums is that they all add up to 360. If we were to do any other polygons, say a hexagon or a heptagon, octagon, and so on, we would find that the relationship is still the same. So the sum of the exterior angles for any polygon, not just a triangle as we learned before, is 360 degrees. So that means it doesn't matter how many sides your polygon has, the exterior or the outside angles will always add up to 360 degrees. So again, the main things you should have gotten from this note is how to find the sum of interior angles of any polygon, which means the inside angles, and that the sum of exterior angles of any polygon is always going to be 360 degrees.